Srini, how was your day?
Hello?
Hello, how was your day? What do you do this morning?
Fine, teacher.
Simon.
That means tomorrow class, then next Wednesday another class. Hello, teacher. Hello.
The internet is very unstable. So you got no class this morning?
Got?
You went for class this morning on Zoom?
Yeah.
What did your teacher do? For physics?
No, normal class.
Now revision. Am I right?
No, not physics.
You can hear me
Teacher,
clearly
I
now?
can't hear you. Your internet very bad.
Can you hear me clearly?
Oh, it's lagging.
Lagging something
Can't
is
hear.
wrong. Yeah, what is happening? I'm also having problem listening to you.
Hello?
Yeah, can hear you. Internet is
No, I
unstable.
can't, teacher. Something is
Can-
wrong.
can
Yeah,
you hear me?
very laggy.
You try using
Something
your
wrong.
smartphone and see. Use your smartphone and see.
Oh, teacher, your voice still lagging. No.
I know. Yours is also the same thing. Try your smart. Okay, can hear me?
I now can hear, teacher. Now okay.
You got problem, let me know.
Okay, let's start the class then, teacher.
Okay, let's finish it for today.
Yeah.
Then after that, we can go past your paper. Okay. Previously, we look at AC in resistor, pure resistor, pure capacitor, pure inductor. Now we are going to look at first resistor and capacitor. Then after that, resistor and inductor. What is happening? I'm having problem adjusting it. Yeah, what's happening? When do you want the next class?
Wednesday.
Okay. Okay. Let us start. Sorry with the delay. What are we supposed to do? RC, RL circuit in series. Define impedance. That's your impedance. Then R square. Memorize this formula. Sketch the phasor diagram for RC, RL. Okay, so it looks like also the three of them together. Okay, just to revise, resistor, this is a phasor diagram. That means the current and the voltage are in phase. For inductor, this is our reactance, inductive reactance, omega L. Remember that your V leads your I by pi or 2 radian. That's how we show the phasor diagram. And for capacitor, same as the phasor diagram. I come first. I leads V. How to calculate the capacitive reactance? 1 over omega C. Okay, let's look at RC in series. There's your R, resistor, there's capacitor, there's your source of voltage supply, alternating source. Right? The thing to remember is the same thing as your DC. The same current pass through the capacitor and pass through the resistor. And then remember that for capacitor, the current leads the voltage by pi over 2 radian. So we can still use the same formula as your voltage supply. That's your V equals to voltage across resistor plus voltage across capacitor. Add them up. Okay, but there's a difference. Right? First, same current, we can use current as our reference line. Then we can draw our VR. Okay, remember we are looking at peak value, right? VR. And right, we are told that your V, your I leads V. So your capacitor will be here, VC. Then we form a rectangle or parallelogram and then find the resultant. That's the resultant V, like V. So we cannot add this normally like what we do in DC. We have to use a vector diagram to add them up because they are not in the same straight line. Okay, so that's a V. So we need to add the voltage as a vector. Okay, so that is your VC here, VC. So to find your V, it's just VR squared plus your VC squared, the formula. Right? Just to remind you, we are using peak value, peak current, peak voltage. So peak also. So we replace our VR with IR, VC with IC, IXC. And then remember that our XC is omega 1 over omega C. Put inside there, we can take our I out. Take our I out. And we get R squared over XC squared. And we can take this I down. Remember, this is peak value, peak value, peak value. Z is V over I, that's your impedance. So from here, the impedance is R squared plus ZC squared, square root the whole thing. Okay, phase difference, phi between I and V, and there's a phase difference. Okay, we can use tangent. Tangent, this is your VC over VR. Okay, and then your VC is just your I times XC. VR is I times XR. We can cancel the I, so it's just XC over R, that's all. Right? Or if you don't want that, you can use cos VR over Z. Sorry, VR over V. Right? So it becomes R over Z, that's all. So current leads voltage by that phi angle, the angle there. Yeah, that's your phase difference. Or we can redraw this one. Right? By right, you use voltage, not resistance or impedance or reactance. Right? But you get the same answer. If you are very particular, multiply by I here, multiply by I here, multiply by I here. It's the same answer. And then that's your phase angle or phase difference. Okay, so we can get our phase difference, that one there, tangent is XT over R. Okay, or you can use sine, you can use cos also, depending on what is given. Okay, remember that formula, all that? The formula for Z, impedance, and then V equals to IR. So R is constant. Right? Your current, your Z, right? Z, you can see that as your frequency increase, your X decreases. So it goes this way. Sorry, the Z goes this way. And then from here, we can get our I, B divided by Z. So as our Z, okay, I think we follow the note here is here. When frequency is 0, right? Learn to read the graph. It's in your book. Frequency is 0 here. The current is more or less frequency is 0. The current is 0. The capacitor blocks the direct current, no frequency. No frequency. Okay, DC circuit, F is 0. So this will be infinite. Right? Infinite, your impedance will be infinite. That's why this one show you going up there. So the current is 0, no current flowing through. For low, around here, low frequency, that one will be quite high. This one will be quite high. XC is quite high. Z is also quite high. Right? And then remember, this is the one that's constant. Z is quite high. Same, you can use the DC circuit. Same thing, same formula. Z high, I will be small. Z high, I will be small. As frequency increases, you can refer to the graph, the impedance decreases. Okay. At high frequency around here, the impedance approaches the resistance R. Okay, because high frequency, this one tend to go to 0 and go very small, almost to 0. So that's why this one, your Z becomes like your R. Okay. So minimum Z is when your Z equals to R. And that's where you get your maximum current. Okay, any comments so far? Just understand the graph, that's all, nothing much. Memorize the graph. Okay, we have a term there, impedance, which we haven't defined formally. When resistors and inductors and capacitors are connected in an alternating circuit, the total opposition to the alternating current is known as impedance. Right? So basically, impedance includes resistance and reactance. Impedance of circuit can be determined by drawing phasor diagram. So we define as Z, the maximum power supply. You have a current flowing through, maximum current flowing through, or root mean square you want to. Right? Peak voltage of power supply, peak current flowing in the circuit. Unit impedance is the same as resistance, ohm. Okay, try this question. Capacitor or capacitance 100 microfarad is in series with a resistance 10 ohm and a voltage source given there. Determine the frequency of the alternating voltage. Yep, how to find the frequency? Ken, Vinny, what is the frequency? From here? From here? Right? 2 pi f is 314. and calculate out F is 50 Hertz. Okay, now how to calculate impedance? Memorize formula. R square plus Z plus X square, square root the whole thing. Yep. Any problem? Calculate your X first. XC, in your value. Omega is 314. C, convert it to SI unit. Use your calculator. 31.8 ohm. Then apply that equation. Z equals to square root of R square plus X square. R is 10. X is 31.8 square. Okay, use calculator. Okay, how to calculate the peak voltage across the capacitor? Same, no? If the capacitor is like a DC circuit resistant, you just need to calculate the reactance times the current, that's all. Okay, so calculate your I naught. I naught is your V naught over Z. Right? V naught from here is a V naught 100. Z, you already calculated out that one. Okay or not? Srini, are you with me?
Yes, teacher.
So across the capacitor, the peak voltage is I naught times X. I naught is 3. Right? That's your X. 95.4 volt. Any comment before I change the slide?
No.
Okay.
Oh, wait. Just give me 1 minute, sir. So the impedance formula is X equals to 1 over omega C.
That one you need to remember. Calculate the reactance. And then the other formula is the impedance formula.
Oh, wait, answer. Oh, okay.
Right? Phase difference between the current in the circuit and the supply voltage. Same. Right? Usually, as I said, if you're very particular, use voltage. Right? The right way to use voltage. But it will still be the same answer because it's just a different in pi only. 10 ohm here, the 33.4 ohm. Right? So that's what we have calculated. That's our Z, 33.4. That's our C part. And cos is just your 10 divided by 33.4. Use your calculator, you get 72.6 degree. Okay. Any comment?
No.
Okay, let's carry on then. Okay, let's try some questions first. Nothing much also. Only 23 only. Okay, 23. Under focus. A lamp marked 6 volt. That's a lamp. And capacitor or variable capacitance is connected in series with alternating supply or root mean square. That's a third word there. The capacitance of capacitor is slowly increased. Right? That one variable capacitor keep on increasing capacitance until maximum value. When the capacitance of capacitor is maximum, its reactance equals the resistance of the lamp. Right? Two resistance are equal. Which statement about the lamp is correct? Okay, what's the answer? Lamp is brightest when the capacitance of the capacitor is 0. Is that right? Go to the formula. We are given.
Don't
Is it right or wrong? That's your XC, 2 pi FC. So the lamp is brightest when the capacitance of the capacitor is 0. If the capacitance is 0, your XC is going to be infinite. Okay now, XC is going to be infinite. So it cannot be brightest. And it doesn't allow current to pass through. As the capacitance of capacitor is increased, the brightness of the lamp increases. Is that right? Yep, right or wrong? It's using this formula. Your C increases, right? F is constant. C increases. Your XC, what happened to your XC? XC becomes smaller. Right? So less resistance, more current can flow. So become brighter and brighter. Okay. C increases. Yeah, C increases. X decreases. X decreases from this formula. So is X decreases, your Z from this formula also. Z also decreases. Okay or not? Anything not clear? Yes, Rini. Anything not clear?
No.
Okay, if okay, we'll carry on. Right, oh, sorry, this is the wrong one. We haven't learned yet. We haven't learned yet. We'll come back later. RL in series. There's your voltage supply, alternating voltage supply. There's your resistor. There's your inductor. Across that is your VR. Across that your VL. Right? Same current passing through the inductor and the resistor. V is the supply voltage. And remember for inductor, your V leads I by pi for 2 radian. Okay? You can think of that resistor as in DC. So we add VR plus VL. But because of this phase difference, we cannot add like your normal. Right? Because the vectors are not parallel. The vectors are at an angle, 90 degrees. So we can do our I, can still draw our I. Our I is our reference. Then our VR and I are in the same direction. Then we can draw our VL. Then form a rectangle to find our resultant V. Right? Power supply. Provide your VR and VL. Remember, this is a vector equation. Okay, so we need to add the voltage as a vector. That's how we get our VR square plus VL square. Square root of the whole thing is V. Okay. Right? Reminder again, we are using peak current and peak voltage. Okay, that's where we stopped previously. Right? Replace your VR by IR and VL by IXL. Right? And then remember your XL is omega L. Place it inside there, take the I out, take the R square plus XL square. Then impedance, take your I down, cross multiply the I to the other side. Your Z is your impedance, V over I. Okay. So we get our Z is R square plus your XL square. Stop me if I'm going too fast. Okay, same. You want to find the phase difference. Phase difference between I and B. This is your I. This is your B. You can use tangent, you can use sine, you can use cosine. Doesn't matter. Okay, so we use tangent. Then it's VL. That's your VL over VR. Right? As before, it's just I times XL, I times IR. I and I can cancel off, so you get XL over R. So the voltage leads the current by phi. Right? Or we can draw the, by right, we shouldn't use that lah, because we are using voltage as a vector, not impedance. But you still get the same answer. There's your XL. This triangle. Triangle. Sorry, wrong proportion. Triangle. This is your XL. This is your V. V corresponding to your Z. Similar triangle if you like. Then that's your R. That's your phase angle. Okay. All right, try this question. A coil, that's your coil, of resistance 30 ohm and an inductance 0.5 ohm, they separate for you. The coil, this coil itself has resistance, so they separate for you. It's a pure inductance 0.5 Henry. If the current flowing through the coil is 4 ampere, what will be the root mean square value of the supply voltage? The frequency is 50 Hertz. Okay, you should be able to do that. How to calculate that? Can? Find the supply voltage. You need to find the voltage across here. Voltage across here. So you have to find the reactance here first. Calculate the supply voltage. Okay, try and see. Don't look at my answer. Try and see. Okay, calculate your XL first. So 2 pi FL. Put in your value. 2 pi. F is 50. 50. L is 0.5. Get 157 ohm. Then Z is R square plus XL square. Put in your value. Calculate out. 160 ohm. So we just need to calculate I times here. We got our Z total resistance or total impedance times our current will give you your V, right? Okay. This one is root mean square. So our answer will be root mean square. Either don't tell you is understood root mean square value. Okay. And phase angle, as I say, you can use cos if you want to. Cos is R divided by Z. We have 10 minutes, so let's try to finish that. Okay with that? Are you okay with me? Anything not clear?
Okay.
Right, here's your phasor diagram. You're asked to draw your phasor diagram. There's your VC, VR. You should be able to calculate your VR, right? From I root mean square times R. So that's your VR. There's this one, Vs is this one, the resultant. Right? S stands for sum, root mean square times Z. Right? There's your 4 ampere. 4 ampere times 160. So that's the value we got. How we get the value. And then, as I say, you can use cos, you can use sine, you can use tangent, whichever is easier for you. So in this case, I use cos R over Z, R over Z. R given Z we have calculated previously. That's how we get our phi. Okay. Now to draw your Phasor diagram in terms of voltage, not in terms of Z, X, and R. Any comment? If not, let's carry on. Okay. Okay. Let's try some question. 24. This one. Your focus. Resistor or resistance R. Oh, sorry. This one is haven't teach you yet. It's our next part. Let's try something else. Try a structure question. The one that we left just now. This one. Number 5. Structure question under your focus. Diagram shows a AC supply. That's your AC supply connected in series with an air core solenoid. This is a coil of solenoid. And a bulb, that's a bulb. M. The bulb lights up with normal brightness. State and explain what will happen to the brightness of the bulb if an iron core is inserted into the solenoid. Okay, tell me what is going to happen if I insert an iron core into the solenoid. What is going to happen? Yeah. What happened to the if I insert iron core into the solenoid? What will happen? Reason it out. Can or not? Can or not? Can or not? Yeah. First thing, formula is important. Right? Increase the frequency or increase L, your reactance will change. Right? So you change the reactance, you change the impedance. Brightness decreases. Why? When the soft iron core is inserted, the relative permeability increases. Relative permittivity increases, you change your L, you increase your L. Cell inductance across the also increases greatly. So that if X increases, in this case, your Z also increases. So also the impedance. Right? So the current become less. Current is just your voltage supply divided by Z. Right? Current in the circuit decreases. That's all. Yep. Are you all right with me?
Yeah.
Okay, we are all right. Okay, what happened if you use a capacitor? Right? Capacitor is, sorry, let's look at the question. State and explain what happened to the brightness of the bulb if a soft iron is inserted. Okay, what happened to the question? I don't know. Oh, I left out the question. Okay, this one tell you what happened to the brightness if your C increases. Okay, same reasoning. Right? Use the formula. C increases, your X decreases. Your Z is total impedance. R squared plus XC squared. So as Z decreases, your Z, so brightness increases because your total Z. Right? As you add a dielectric, your C will increase. The capacitance will increase. The reactance, that increase, that will decrease. If that one decrease, your Z also will decrease. So your current is V divided by Z. That's your voltage supply. Right? There's your impedance. So your Z decreases, your I will increase. So the heating effect will increase. That's why the brightness will increase. Okay. We'll take 5 minutes break if you are okay before we finish our last part. Are you okay?
Yeah, I'm okay.
Okay, then we take a break. We take a break, 5 minutes break. Let's finish the whole thing.